showed up at the field day, as Ron said, and I talking too close to this, or is that okay? I'll get the mic right. But mainly to get out of I wanted to meet some of the guys from Tucson and get out of the Phoenix heat. So 9,000 feet sounded really good, and I think it was June or so. But been doing some 10 gigahertz work with some folks. I know you've got some folks down here in Tucson that do, because I've got some of my longest contacts are actually with some of the Tucson guys. They were contacts that I made from San Diego, actually. The picture in the slide that's up here is actually taken off of Agassiz Peak up near Flagstaff. Humphreys Peak is sort of in the background just a little bit there, and is a little bit taller. But I'm going to step through this tonight fairly quickly, but I'll be glad to answer any questions or to go more into depth with anybody who wants to after the fact. Because I know there are a lot of slides in this presentation that go over things like band plans and detailed tweaking of local oscillators and all sorts of things that most people may or may not care much about. Excuse me? I've got a little bit of audio with me this evening as well, and I'll try to go through this, but the table of contents in the presentation just had a little bit of we discussed the amateur bands a little bit in the microwave range and getting started, what you need to get started, how much does it cost, what's available in the way of commercial equipment, that type of thing, what's available as far as surplus equipment. And I have a commercial-based solution that's behind me here that we can take a look at if you want. That was for this year. I built a surplus-based equipment version of this for the 2008 contest, and then there were a couple of contests this year. Mainly the contests. I'm really not too much of a contest guy myself, going for the points, but when you're dealing at 10 gig and up in the microwave bands, there's really nobody to talk to. It's a pretty lonely band out there. You don't just put up a carrier and start calling out CQ, because nobody's going to answer typically. Most of the contacts are pre-scheduled. During the contest weekends, though, there are literally hundreds and hundreds of people, or maybe even thousands across the U.S. that are doing this type of work. So, naturally, it's a chance to get a chance to make some contacts with other folks. Real quickly, the bands. The band that I specifically was in was a 10 gig. It's referred to as X band, but it's when you're dealing at the 10 gig level here. This is they call it a 3 centimeter band. It's technically 2.77, I believe, and that's about an inch and an eighth. So the total wavelength is a little over an inch. It's well under an inch and a half. You'll notice that the band is actually 500 megahertz wide, and the next band above that, that's an amateur band, is a 24 gigahertz band. And then there's 47, 75, 119, 142. There are several bands that the amateurs are allowed to transmit in, but frankly, anything above these two. There's a few 40. I know a few folks that have done 47. I don't know anybody that I'm aware of that's done anything above that. I saw a picture of a 79 gigahertz radio one time, but that was about it. I've never seen one in person. Now, the majority of the people in the contest will be at 10.368 gigahertz in this 3 centimeter band. There will be a few that might try some 24 gigahertz type work in the contest as well, but and there is specifically a 10 gig and up contest that happens twice a year, and it's once in usually in July and once in August. August and September. Excuse me. There are. This year it was, this is the band plan again. I'm just going to skip over this. This talks a little bit more in detail about where propagation beacons are and things like that. As far as getting started goes, you really need, your equipment is you really need some type of transverter and an IF radio. And the IF radio can be a simple all-mode 2-meter rig. Most folks use an all-mode rig because most of the communications that's going to go on is either going to be CW or single sideband. We can do FM, but there's not that many people that start out at FM at 10 gigs. So the transverter that I'm referring to is actually a piece of equipment that will connect to the 2-meter radio And everything that you do at 2 meters then gets translated up to 10. And so if you're transmitting at 2, you'll transmit at an equivalent frequency at 10. And everything that's happening at 10 that you're receiving is coming down and being converted to 2. And that's what's actually going on in this radio over here. The radio shows 144.301. Well, that's actually 10.368 gigahertz. It's 10.368301. And so everything is 10368 plus some offset 144 megahertz. And it's all being scaled up and scaled down. Now transverters can be built, they can be purchased commercially. Down East Microwave and SSB Electronics and Pune Electronics in Germany all make equipment. The equipment that I have on this was made by Pune. The guy that owns Pune Electronics is also a ham. DB6NT is his call. And I think he started the business as really a side thing, building ham equipment and transverters. This is a picture of the Pune Electronics transverter, and you can see a little bit of the circuitry inside. It's all strip line. It's all done on surface mount components, quite tiny. You can actually order these up as kits if you feel the need to build your own equipment. You can put it together from a kit, but you better be pretty good at identifying surface mount components and soldering them as well. Basic overview of the transverter. I'm not going to dwell on this much at all, but you've got a local oscillator and a mixer, and so you're mixing the local oscillator, which starts out generally at something in the 98 to 100 something megahertz range, and then gets multiplied up. And you're mixing that 10 gigahertz with the incoming signal, and you're either getting in this case, the resultant local oscillator is different by 144 megahertz on the particular transverter that we're using here. And so you've got a high side and a low side after the mixer. You get 2 different frequencies, but in this case we're using the low. Down East Microwave has a little bit of equipment available, and then there's also the surplus equipment possibilities. The surplus equipment, this box that you're seeing in this slide is actually something that came from, was a commercial product in the 70s and maybe even the early 80s. And you can do conversions on these. They were close to the 10.368. Most of the amateurs that operate tend to operate at 10.368 gigahertz. Even though the band's 500 megahertz wide, almost nobody uses anything outside of 10368. And even that is narrowed down to within a 500 kilohertz span or so. So it's like 10368.0 to 10368.5. Excuse me. In this particular case, this local oscillator had 103.0794 megahertz crystal with 102 multiplier, and that resulted in this local oscillator frequency of 10.514 gigahertz. And if you subtract out, if you use the high side and low side, or the sum and difference, you find that 10368 comes up at 146.1 megahertz. So that's within the span of a typical 2 meter all mode rate. That required retuning all of this because this whole thing was set up for commercial frequency, which was outside that 10. It was above 10.5. And so we brought all of this back down. And you notice, I mean, you look at the construction, there's a whole bunch of tuning screws, and these things are filters, mechanical filters. There are aperture filters and cavities. You have to go through and tweak all these up. It's interesting and kind of fun. This is a version. This is the mixer itself, and from the other side, you're seeing the bottom side of this right now, and the waveguide output here. And here's the top side view. This particular transverter, I used some of the equipment at the bench, a spectrum analyzer, to adjust all this in. This particular transverter was put together with so you got the local oscillator, the mixer, and the power supply here. And this whole thing was turned into a rig that was a home brew. The back side had a 2 meter radio on it. The front side was all the mixer and local oscillator. And then that all got put together on a tripod. I guess me pointing at my screen is not going to get you. All this got put together on a tripod here. You see the radio on the back side and the electronics right behind the antenna feeding this antenna. And this was in 2008 and on the August contest, and this is up on Signal Hill in Long Beach. The radio, that particular rig weighed about 156 pounds between the radio and the dish and the tripod and everything. So Coming up for this year's contest, I had big plans of going up on the side of Agassiz Peak, or Humphreys Peak, and I thought I was going to have to backpack the equipment up there. And 156 pounds didn't sound very exciting because I was going to start hiking at 9,000 feet and hike up to 12,600. And that in itself is a chore. So I decided to purchase some off-the-shelf equipment that was much, much smaller and had a lot better characteristics than the equipment that I had, than the surplus equipment I had before. That surplus equipment, for what it's worth, cost me, I might have spent $100 on that project. The equipment was virtually nothing. It was donated, and I did put together, I had to buy some connectors and things like that. So it really doesn't cost a lot of money to get into it. You can get the surplus equipment and talk to people and get set up. This off-the-shelf equipment, the only piece of off-the-shelf equipment here that was really required was this transverter, the power amp, and the LNA, which is kind of just add-ons to improve performance, output power, and receive sensitivity. But the total cost of those three items is about $1,000. So, there's a little bit of investment there if you decide you want to go the commercial route. Most people end up starting in a mode that starts them off with some surplus equipment first. The ICOM radio was out of my truck, so I just used a radio that I already had that would do an all-motion meter. So, well, this just explains that I was going up on Humphreys Peak, and I wanted better performance and lighter weight. So I went with a commercial solution. The commercial solution, this shows a basic block diagram of the transverter. It's coaxed into the LNA, and this is the low noise amplifier for receive, and this is a power amplifier for transmit, and that's switched by a relay to the front of the antenna. There's a relay up on the back side of this. The LNA is over here, and the power amp, and then the Kune Electronics transverter is here. I've got an ICOM 706 that I'm driving now, is where I'm using as an IF radio. The 706 turns out to work a lot better in daylight than the 7000. The 7000's got that vacuum fluorescent display. You can't really see it when you get it outside in daylight. This is the backside of what you see behind me as well. Kind of identifies what some of the stuff is there. I have a rubidium frequency standard here as well, because one of the things that's a problem with either the off-the-shelf equipment or with the surplus equipment is drift. The local oscillator that you're using, even if you temperature control it, a drift of a few parts per million gets multiplied by 100 to 1 on the way up. And so now all of a sudden you've got this radio drifting all over the place, and if you're trying to hold a conversation with somebody, you end up, it's just everywhere. I mean, some of the guys occasionally refer to these people as fast movers. You line up on them, and then you almost continuously scan through the dial just to keep them, just to keep hearing them, because they're moving several kilohertz per second almost, and it's going right up the band. And then it'll slow down and it'll turn around and come back and everything. And so a lot of the local oscillators that are not very accurate, they're not very stable, rather are really a problem to deal with when you're trying to make contact. So I went with this rubidium frequency standard, and it has a 10 megahertz output that's very, very stable, and that's used to stabilize the local oscillator that's in the transverter. Somewhere here I've got some audio as well and some video too that I'll show. Okay, this is coming up on the first contest weekend, and that was the picture you saw at the beginning. This was located up on Agassiz Peak at about 11,600 feet, or 11,005 as the slides indicated. I got the equipment up there. Turns out that I was originally wanted to operate from the top of Humphreys Peak. And Humphreys Peak would require me to hike it all up, and I was going to have a friend go along with me. That was going to be quite a little chore, but as a backup plan, just in case Humphreys Peak kicked my rear end, I wanted to have a backup plan to operate. And there's a ski lift up there that goes to Agassiz Peak, which people ski down from Arizona Snowball. So I got in touch with the snowball owners and said, hey, is there any possibility that we could haul this equipment up on the ski lift if for some reason I hike halfway up Humphreys and decide this isn't for me and have to come back down? And the guy said, well, yeah, I don't see any problem with that, but we should really ask the Forest Service because we have an agreement with the Forest Service. So So I got in contact with the Forest Service and said, hey, planning to go up Humphreys Peak and do this. And he said, you're going to do what? I said, so I started explaining what the microwave dish was. He said, you're going to put up a microwave dish on Humphreys Peak? No. I just want to haul it up. And this whole thing turned into a big explanation to one of the guys at the Forest Service as to what I wanted to do. And I finally showed him some pictures of what the equipment looked like. And he said, well, I said, I really just wanted to pick Agassiz Peak as a backup. And he says, well, he says, I think I'd rather, if you don't mind, I'd rather you work from Agassiz Peak instead of Humphreys. And I said, well, okay. And I wasn't exactly sure why, but then he says, well, he says, Humphreys Peak is in the wilderness area. A couple hundred people go up there on the weekends. And he said, these guys get up, they just hike 4 or 5 hours up the side of the mountain and they pop out and you're standing there with a microwave dish. I don't know. He said, I think maybe, that kind of spoils the wilderness thing. And I said, well, all right, I see your point. So the backup plan became the officially approved plan by the Forest Service. They actually didn't want me operating from Humphreys Peak, so I probably could have pushed that a little bit, but I don't know if they could have kept me out or not, but I didn't care, so it was only another 1,000 feet up. And as it turns out, I would have never made it up anyway, so after just hauling this gear up even to where I'm at was a chore. I did ride the lift up with the equipment to get it up to about 11.2, and then set it up at 11.5 up here. But that particular weekend that the contest was going on was also a special event weekend where they were having this climb for the cure type of thing for I think it's a Susan B. Cohen cancer deal. So they had the road closed down. So I was going, and the ski lift was subsequently closed as well that day, so I actually had to hike up the mountain, although I was able to do it without the gear, and so operated from up top. There's a pretty nice view from up there. You've got about 130-mile line of sight visibility and about 140 or 45-mile radio line of sight from there. And this really explains what I just told you about the Forest Service. But I do have, by the way, copies of 4 or 5 printed copies of this and about 10 CDs. If anybody is interested in the information that's in it, you can take these with you. I'm going to see if I can show the August video here now. This might get interesting. So. There is some audio with this, but I'm not going to bother on this particular time to do the audio. Let me try to zoom that in a little bit for full screen. There was some audio, but the majority of the audio was taken during some very windy conditions, so it really doesn't do much good to play the audio of this anyway. But that was the ski lift I was talking about, and this is an area of about 11,200 feet. Went up on a Friday and did the setup gear, and then the contest was Saturday and Sunday in August. It was really nice up there. That particular Saturday, we got up to 56 degrees for a high. It was 40 in the morning, and this is the middle of August in Arizona, so the altitude was really my favorite. There was one other guy with me who makes it up fairly soon. This is actually on Saturday morning.
Actually almost another 1,000 feet above where I'm at right now. Although we're going to be heading up the mountain just a little bit. You can hear it's a little windy this morning. I haven't looked to see what the temperature is yet.
We started out in the parking lot at 9,200 feet. We've gone about 400 feet. Only 400 feet up. About 400 feet up, 2.5 mile high. He said, wow, this is really hard. I didn't know that on the trail. He made it up about 3.5 hours later, and he eventually begged me to leave him behind and just go on my own. But it was quite a hike. And starting out at 9,000, the altitude is already really something you could feel, and then hiking up the rest of the way was pretty intense. It's not something I'd done before either.
The rig, we've got the position here. Please keep it from blowing over.
People tried to see the road come up and spent the better part of the day actually answering questions as opposed to making contacts. But did try some contacts in the Tucson from up here, and were not successful on any of them. The distance wasn't really the problem, I don't believe, but there's the real problem, I think, was just the edge of the mountain was kind of in the way. Tucson was kind of on the other side of the rock there. I didn't have very good visibility in that direction, so. But I nearly tripped over a rock there. This is a little lighter version of the tripod as well. And see the equipment here. The radio that's up here is just a little 2-meter handheld. And with that little rubber duck antenna on there, I had about 160-mile contact into a UHF repeater in Kingman, and from that altitude. And I was using that as my coordination into Southern California. Everybody in Southern California and some in Arizona operate on Cactus Net, which is a bunch of linked repeaters, and I believe it's privately held, if I'm not mistaken. You need to join or something, but they opened it up during the 10 gig and up contest, and we coordinate our calls, and we let people know that we're waiting, or we use it to indicate that we've got our carrier up, things of that nature. So these contacts are usually coordinated. So, for example, I'll indicate to somebody in California that I'm ready to send a carrier towards Fraser Peak in Los Angeles area. And if somebody's ready to listen, they will, we'll coordinate that, and I'll say, okay, I've got carrier up, I'm at this frequency and whatever, and they'll try to find my carrier. If they find it, and we establish a one-way path that way, they'll tweak up on it, and just line up and try to maximize the gain or maximize the level of the signal that I'm sending out. At that point, we'll use the UHF frequency and say, okay, we're going to drop your carrier, and I'll drop. They'll put up a carrier, and I'll do the same thing, and I'll tweak up in that direction. At that point, we're fairly well lined up, and we'll go ahead and then actually hold a conversation at 10 gigahertz. So it does require some coordination. Now let me see. A few more slides in here that we've already discussed anyway, the temperature for the day and the visibility and that sort of thing. These were the contacts of the day, actually of both days. The trip up Agassiz Peak was really not very worthwhile. It wasn't bad, but I spent 17 hours at 11,000 feet in a lot of wind and height and everything else, and made 6 contacts, and 2 of them are the same guy. 6 contacts and 2 of them are the same guy. And so that really didn't. It wasn't exactly what you'd call earth-shattering. However, if you notice, 3 of the contacts are 316 miles. And on 10 gigahertz, that's actually pretty good. Those 3 guys are all K6s there, and they were they're from Sixland. They were all from California. So those last 3 calls were made into Delta Mike 12 Tango uniform, which is an area just outside of San Diego. And so from Agassiz Peak in Flagstaff to San Diego, 316 miles over dirt with 10 gigahertz is really pretty good. Over the ocean, you can get something called tropoducting that can occur between a marine layer and the surface of the ocean. And this can extend out several hundred miles, further than this even, but 600, 800 miles. But over dirt, you're pretty limited. You're either bouncing this stuff off of a rain cell. You can bounce it off of mountains. You can bounce it off of thunderstorms. You can bounce it to a limited degree off of airplanes, although they tend to move fairly quickly. So you don't get very much time, but it's sort of like meteor scatter. I mean, you can do a little bit of work there. But you don't have very many propagation modes. The only thing you do have, in some cases, is knife edge diffraction, where you're essentially breaking the beam over the top of a fairly sharp ridge of mountains or something of that nature. And that does work. And that is, in fact, pretty much what we think we were doing into San Diego. And then in the second weekend, we did that from San Diego back into Tucson. So made some contacts in that path. And that's actually that path it was surprising to me at the time, but sitting on Agassiz Peak talking to San Diego, I assumed that was a longer path than San Diego to Tucson, but it's actually not. Tucson's about 10 miles further from that San Diego area than Agassiz Peak and Flagstaff is, because you're so much further east. And but in any event, it was still fun. I got to have a field day. I got to hike. I got to be on the side of a mountain. It was cool, and I got to do 10 gig work. So all in all, that went pretty well. This was a QSL card that I sent to the folks that I contacted from Agassiz Peak. It was just something I made up that was taken from up there. And then we get into the second contest weekend. Now, on the second contest weekend occurred a month later, and some of the individuals that I contacted, and the three individuals, in fact, that I contacted in San Diego from the side of Agassiz Peak called and invited me to go over to San Diego for the second weekend and make contacts in the various places in California and back into Arizona. And so I went over there and spent that weekend with the California guys that I talked to the previous month. And here were some of them set up. I don't remember all the call signs. Well, the call signs are listed on the slide, but it was Greg Bailey and Lee Schleppman and Kerry Bank. These guys all had their own equipment, and we set up on a mountain called Miguel, which is near San Diego. It's not very tall; it's only a couple of thousand feet, but it does allow some pretty good contacts. We were also directly under a 110,000 watt UHF transmitter, or under the antenna. The transmitter was in the building next to us, and I'm not really sure. That didn't seem to have any effect on any of the stuff we were doing, but I can imagine that the fields were pretty intense up there. The contacts made the second weekend, as you can see, are significantly better. There are many more contacts, and some of these contacts are fairly long, actually. Here are a couple that were 283 miles. I didn't even realize that these contacts were as long as they were until after the contest was over. What had happened, and you'll actually hear some audio from this in a minute, but what had happened was that we were operating from San Diego, pointing towards a mountain in Los Angeles, and that mountain in Los Angeles was on the same heading that these people were at, but they were actually up near Kettleman City. And so Fraser Mountain was about halfway in between where they were and where we were. And so as we're talking to people on Fraser, all of a sudden I get a call from these two guys, or from one of them actually, and thinking, oh, it's more people on Fraser, but they're not on Fraser. And we're using Fraser as knife edge diffraction up into Kettleman City because this is way past the curvature of the Earth. You don't get a 283 mile path without refracting or bouncing or doing something. It's just not. And in fact, there's a slide in a little bit that will show you the communications path into Tucson. There was also a 240 mile call in here that this WA6 CDR was a guy named Robin that was operating off of a mountain near Las Vegas, and then there were these calls down here, which were all actually in the Tucson, or two of them were in the Tucson. KI5WL and KJ7OG. I'm trying to remember those individuals' names. I think one of them's name was Steve, and the other one, I don't remember the other one, but they're both local guys here. And those were 326 mile contacts, so they were pretty good. I don't have some audio of the Tucson contacts, but I do have a couple of slides that have audio on them. Let me see what's next here. Okay, this is not it yet, but I do have some video a little bit of video here, and let's just go ahead and show that for a second. There's a little bit of audio here too. I'm not going to bother to play it, but this guy was Greg Bailey. This is his lab. And he's holding this balloon because
right?
he's proud of the job he's done on the lab.
This is HD. I won't have a release for the guy in the room.
Cleanup job, but it looked a little unorganized to me, but he's an electrical engineering professor at I think it's Southern California, San Diego. And we were heading up Miguel Mountain here. I don't have much video at all on top of Miguel. We were almost run off the mountain by a fire that day. We were commenting. There's no fire yet. That's just some of the morning fog. But this is about 8 miles from good camera work here. Here's where we were set up, and we get a little bit of a view of some of the towers that are around us and that type of thing. But this view out past this fence is up towards LA. And we just shot right through the fence. The fence is no problem.
Right here, just so I can tell what my radio's doing. Otherwise, I don't know what I'm doing.
He's trying to figure out how to use the radio again. He's got it all over there. He's once a year replacing it. And, but we operated up here, made several contacts. Some of them were out over the ocean. I made one contact with Golden West. He was in a boat located there out in the ocean. There were all the contacts that I made on the first day of the contacts were from here. The Tucson contacts were actually made from a different mountain, which is about 6,500 feet, and that mountain, there's fire popping up. And it was pretty close, as you can see. We were afraid we were going to have to pack up and head down the hill in a hurry. Fortunately, the aerial tankers came in and tamped that down pretty quickly, pretty short order. And it's there you can see some of the planes are fighting, but it was a little bit exciting. But we headed down for the day and headed out to the second day where we made some further contact. At the same time, I'm going to go ahead and just go straight to some audio again. There wasn't much video left for the second day, but let's go back to the presentation again, and then I've got a couple of audio clips. I'm going to try to, I'll explain them first. There's two of them back to back on individual slides, and hopefully you'll be able to hear them, but they're actual communications and contacts that we made. Let's see, where's the... It may be on the next slide. Yep, it is. Okay, I've stopped it here. What you're going to hear, and I'm going to try to put the microphone down here and get it fairly close. You're going to hear some unintelligible language at first because the frequency is slightly off. I'm going to tune in, and this is a 283-mile contact that's shown on the map to a guy in Kettleman City.
W6QIW, this is Alpha Delta 7, Oscar, India, and Delta Mike 12, Mike Quebec, QSL. QSL, and we're Delta Mike 12, Mike Quebec. I got your call, but I didn't get your grid at the other frequency, so what's the grid there, please? Delta Mike 95 something?
That doesn't sound quite as good as it did without our. By the time it's gone through the presentation and the speaker and the mic here, but I don't know if any of you could hear it or not. But that was one of the contacts. Okay, good. There's another one here. The second one is perhaps a little better, and it was a 240-mile contact. The thing that's a little interesting about it is where it goes. It's up to Las Vegas, but when we draw a line up towards Las Vegas, we actually cross Interstate 10 at an area where there happen to be a bunch of windmills. What you're hearing now, this is me putting out a carrier where the other guy was. I dropped my carrier.
WA6DR, WA6DR, WA6DR. This is Alpha Delta 7, Oscar, India. Alpha Delta 7, Oscar, India. Alpha Delta 7, Oscar, India. We're at Delta Mike 12, Delta Mike 12, Tango Uniform. That's Delta Mike 12, Tango Uniform. Delta Mike 12, Tango Uniform. Hear this?
I'm repeating my call sign a few times, but when he replies back, you can listen to his audio, and it's a little watery sounding, and this is, we believe, caused by the reflections of all.
I copy your Delta Mike.
So in any event, his audio was kind of interesting. It was easier to hear, of course, being there the first day and all, or being there listening to it directly, but it was a very watery sound, like there were many, many reflections coming back. And once we plotted the line, we found out that it goes directly over the windmill farm near Coachella and I-10. And so we're presuming a little bit that that's the reason for that. This was actually the rig, and it's actually pointed at Tucson in that picture. That was the view that we had towards Tucson, and I had 2 successful contacts into Tucson at the 2 call signs I mentioned. This is why the 2 successful contacts don't work. This is an actual plot of the curvature of the Earth that, let me get my pointer here. This is done with a program called Radio Mobile, which is free, but these are based on an actual curvature of the Earth and topographic data from topo maps. And you can see the path is is a straight line path through the Earth, or if you try to get over the curvature of the Earth, this would continue on into space and be way, way above Mount Lemmon. So this was a Mount Lemmon to the mountain we were on. What's happening here is that our signal is refracting off of this edge of the mountain here and bending back down. There's also another one here, and presumably that's allowing the path to occur, but clearly there were no storms, there were no storm cells to bounce off of. There certainly wasn't a marine layer out of the middle of the desert in Arizona in September, and it's a little uncertain as to how you make that contact, but it does work and it's repeatable. So this was one of the last slides, and it's just the total QSOs made during the contest and their distance. They're listed both in miles and kilometers. The contest is actually done in kilometers, but I listed them in miles, of course, because we're a lot more familiar with that typically. But the longest contacts are all here between either San Diego and Agassiz Peak, or between San Diego and Tucson here. And just for reference, the antenna on this, I didn't mention it in this was the QSL card given out for the contacts as well. The antenna here is a 33 dB gain. We're putting about 2 watts into it. And so the effective radiated here is about 4 kW. So it's just very narrow beam. It's less than 3 degrees wide, but it's still about 4 kilowatts. And that's it. I'd be glad to answer any type of questions or anything anybody's got. Yes, sir?
When you're making contact with, say, Mount Lemmon from San Diego, how many degrees do you have to be within to make contact?
Yeah, the question was if we're making contacts from someplace like San Diego to, say, Tucson or something, within how many degrees do we really have to be? It doesn't, the beam width is about 3 degrees or so on this particular dish. It would depend upon the dish. But in reality, I use, this rig has a small compass on it, and I use that compass. So I will pre-plot it out or figure out what the heading should be. Just lining up the compass, which is not going to be accurate within 3 or 4 degrees anyway, that gets me pretty close. At that point, while pointing in that direction and pointing basically at the horizon almost always, it doesn't matter how far away the contact is, pointing at the horizon, so I'll either put up carrier and let somebody listen for me, or they'll put up carrier and I will listen. And I'll just scan back and forth a little bit. And the problem is not only do you have to scan back and forth and up and down, but you also typically have to scan in frequency a little bit too, because some of these folks don't have stabilized oscillators or whatever. They might be 3 or 4 kilohertz off, and 3 or 4 kC off on a single sideband radio. You're not going to hear them at all. And so, sometimes it's a crapshoot. In fact, one of the reasons for as few contacts as I had the first weekend was the fact that the equipment was all new, and I found out later that I was overdriving the transverter with the output of the frequency stabilized source, and I was actually pushing myself 120 kilohertz off. And so there's just no chance. There were a few times that I tried to make contacts at the Fraser Mountain in California that just didn't succeed. But I'm quite certain that they probably didn't succeed because I was nowhere near where I was supposed to be. And but you can scan around. It's not that hard to do. It's not like you have to be very precise. I mean, it's still the beam width is 3 degrees, but even that's only the 3 dB point, and typically your link margin is a lot more than that. And so it's not as bad as it sounds. Now, one thing that I didn't mention in the presentation is how well some of this stuff bounces off of various obstacles. in order to test equipment in Phoenix, I made contact with AD7OI, Ron Phillips, and we were only about 10 miles apart, and that was almost too close. I mean, both of our meters were 60 over S9, just banging. So Ron says, well, can you see the mountains north of town? Yeah. And he says, well, point at them. So I pointed my rig at the mountains north of town. He pointed his rig at the mountains north of town. We were right angles to each other. Our antennas weren't even pointed at each other. We're bouncing off the mountains north of town by 40, 50 miles and back, and we're still holding a 20 over S9 conversation. It's just no problem at all. So, the stuff bounces everywhere. When we lined the radios up initially, Ron put one rig in the back of a car and pointing out the back of a hatchback, and I set up a rig in the back of our building pointing out across the parking lot. Well, as soon as you get to the end of the parking lot, there's neighborhood houses and streets and everything else. We had communications for over 2 miles before we lost it. It just bounces down the street between the houses and everywhere. So you're really flooding the area. Any other questions? Oh, I'm sorry. Yeah.
Yeah, I listened to the coordination of the contest on Cactus. I don't remember if it was the first or second weekend, probably the second. And I've never heard Cactus so busy and everything. I mean, Robin sat there, and I know he worked 3 or 4 weekends making Cactus, fixing certain peaks and everything. But it was a lot of fun listening to the contest. I was noticing radios and everything. And given the 10 gigahertz and everything, is anybody using SDR receivers or SDR radios with pan adapters?
Not that I'm aware of yet, but I'm sure somebody probably does. And there is a new one, I think, from Flex that actually works at 2 meter. Maybe all of them do, I don't know. But I may actually be doing that next year. I'm already planning to perhaps purchase an SDR. But one of the problems was that I don't know that there were SDRs at 144, and that was what I needed as an IF frequency.
Yeah, well, you have to sit there and use the converter right now. Flex is coming out with the 2 meters. Of course, they're coming out with that Flex 1500, which is like $500 or $600 with the converter in front of it. And it looks like it'd be ideal for it.
Yeah, I agree. When I saw that, I thought that would be very good. Any radio that has DSP filtering in it or anything else works very well with this too. I mean, because I noticed that when I used the Icon 7000, that I wasn't using the 706 during the contest. I had a 7000, and boy, the noise reduction on it really helped a lot. And pull signals out, and so.
I was thinking about the pan adapter and waterfall display where you can sit there and see somebody, up and down the band.
Yeah, and if I was planning actually this year to take a spectrum analyzer, because you can get to the 144 meg quite easily, and just that way you could see somebody's signal that was 100 kilohertz off or 10 kilohertz, because you could center up and just watch and see if anybody's popping up anywhere, because you only really need to look at about 500 kc wide section or less even, and most people are operating in 200 or 300 kc of it. Other questions? Yes, sir.
Is that a stock feed horn, or have you modified it?
A stock which?
Feed horn.
Oh, feed horn. Yeah, that's actually an X-band stock feed horn from a Microwave Associates link. It's a 2-foot dish, 33 dBi, but it's I think they call it a shepherd's crook or feed, and it's there are different feeds. There are penny feeds that are that shoot up the center and reflect back down. This one actually comes out, bends around, and points back. And so there are various types of feeds, but it is an unmodified dish at this point. And I am looking for a bigger one, by the way. If somebody's, I want a dish in the 4 to 6 foot range, spun aluminum preferably, or something of that nature. Well, they exist. I'm looking for one, so if anybody has one, let me know. But one of the easiest things to do to improve performance on these is to just increase the dish size. I mean, it's you can get a lot more gain with the dish size. I mean, you double the size of the dish, you're not just doubling the gain. In this case, I mean, I've got a 42-inch dish that's an offset feed, and it has about 41 or 42 dBi gain. Instead of 33, well, you start doing that math, and that really. I mean, now all of a sudden you're over 10,001, and pump 2 watts into that. So one of the guys in San Diego had I think it was a 7 or an 8 foot dish that he was putting 20 watts into, and we calculated the power. He beamed that back towards Agassiz Peak, and that's what I used to line up on. We had a 20 over S9 conversation from San Diego to Agassiz Peak, or at least his conversation was 20 over S9 to me. If you start calculating that, it's somewhere in the neighborhood of 250 or 300,000 watts EIRP, so it's a lot. Other questions? If anybody is interested, there are 4 or 5 printed copies here, and there's also some CDs that have the video and the presentation on it. Also, if you really are interested in the 10 gig, there are several people. There's some in Tucson here. There are some in Phoenix, and somebody would be glad to help you out, get you started, or anything else if you've got questions or you want to get more detailed or more involved in it. But it really is a heck of a lot of fun. I've had more fun with the 10 gig stuff. I mean, there are things that I just wouldn't have thought possible. I was of this mindset that you've got to have this thing just pointed absolutely critically close and everything else, and that's really not the case. There's a lot of things that you can do to have some real fun. Well, in any event, I guess thanks everybody. If you got any questions or anything else, please see me, or if you have any questions about the rig.